So a very warm welcome here to the Parker booth. Parker is proud to be the global leader in control and motion technologies. And Parker is here at bauma with the motto, technology inside to move your world. And Parker aims to fulfill your wildest design, engineering designs, and also with rock-solid solutions for mobile machinery and off-road applications. Here in our talks at bauma, we have invited experts from all over the globe to share their insights on the 4 key themes that we see driving the industry, and those are electrification, digitalization, mobile hydraulics, and clean tech. Up next now, we're going to be talking about safety and cybersecurity considerations in your electrification of the mobile machinery. It's my pleasure to introduce our 2 speakers, so I'll hop over here. All the way from Cleveland, Ohio, has a ton of experience and your very first time at bauma.
Very first time.
Right. You're program manager, electrification at Parker's global electrification team.
Correct.
With over 30 years of experience in the motion and control industry in many roles. A very warm welcome, Rich Nagel. Lovely to have you here. And our second expert has been to bauma many, many times, usually draws in the crowds to share his expertise. He manages Parker's Mobile Center of Excellence, EMEA. He brings over 35 years of experience in system engineering and application software with a focus on mobile electronics and hydraulic systems. Welcome back to bauma, Nils Henriksson.
Thank you.
Dear visitors, you have the opportunity after our talk to ask our experts anything you would like to know about cybersecurity in your mobile machinery. Let's get cracking. Nils, what are the key drivers for digitalization?
Yeah, so as you can see, it has been a journey for all of us, especially when you coming from mechanical solutions, going into more and more electronics in all of our machinery. And you can see how to compete in the future will actually be by the software. But here you can see a couple of examples. We can talk about brake-by-wire, we can talk about steer-by-wire, we can also talk about how to do electrification on the different solutions. But you can see a lot of impact will happen how to make a machine safe when you talk about software and how to make the software solid. Compared to in the future, in the past, we did a lot of safety on hydromechanical impact. And maybe you can like to add something here, Rich?
Yeah, I think obviously the biggest change for us is we've come from a mechanical world where safety was fairly easy, it was visual, right, to a digital world where really safety is inside the box. And people don't always understand really what safety and cyber protection entails. It's not something you just plug into the wall and it happens.
Okay, so it's electrification that's driving the digitalization and the benefits of the data that you can get out of that.
But also productivity, I would say, because you can see out in the booth here, we have the next generation hydraulics prepared for high performance. You have digitalization to increase the performance as well with a lot of automated functions, autonomous functions, what will coming up. We need to be prepared. So electrification, of course, you can't do it without any electronic controllers in the system today.
Okay, so it has its benefits, but as you open up your machinery or digitalize it and electrify it, then you're opening it up to possible threats, which we need to discuss now and manage. What are some of the key elements of a safe machine then?
I would like to say, when we have started to work with functional safety in a machine, you can see here on the left-hand side, it's so much about the V model. You're defining what the machine should do, you're defining how products should be selected, and you work on it. But you can see on the other side, you're also doing a lot of verification, what need to be designed into the system to make a machine safe. Now, on the right-hand side, you can actually see how the impact and what can be a threat to us if you don't can protect your key parameters, your key software into a system.
And I would add for functional safety, there's some additional elements. How does safety affect intended use of the component? So we know that our customers are going to use our equipment a certain way. We design safety into that. But there's also misuse. And of course, things happen, especially in work sites. Cables get cut, right? Machines are on not always flat surfaces. And so we create unsafe conditions that we don't always anticipate. But our job is to anticipate and design around that, both at the component level and the system level. So the digitalization, right, and electrification, they're really tied together. I mean, I think electrification amplifies what's already going on in some of the machines today.
Okay. One of the things, I mean, you've got here is the Cyber Resilience Act. So when you say key elements of a safe machine, what about, and you say anticipating, what about being one step ahead of regulation? What can you recommend for that?
I would say we are here and we follow the European legislation and we need to be prepared for it. But it's not only to be compliant with the standard, it's to have this standard into the daily work. Approaching a customer, talk the same language, see how they are working with it. It's the key element to be a good system provider and also support our customer to be short time to market.
And ideally be one step ahead of regulation, right? That's
Yeah.
when you avoid mistakes. So what are the specific design requirements and procedures required for a safe machine?
Yeah, we talked a little bit it before. We
Yeah.
can see that on the left-hand side, the V. The V model coming out from performance level on 13849 standard. And that is probably the fundamental impact. But you need to do risk assessment for it and so forth, of course. But that, I think, is fundamental, very important. And I would say also on the CRA, you can see that is the same thing, defining what will be your threats.
Is the V model specific to mobile machinery and off-road applications, or it's...
No, it's
No.
not. It's the whole machine directive coming down. So if you do an industrial, if you're doing something on a mobile machinery, the design procedure is similar.
Okay, and are there any of those specific requirements in the mobile machinery and off-road application that differ to, let's say, automotive vehicles in the considerations?
Probably speed and where it
Yeah.
is. So, I mean, in the end of the day, when you do your risk assessment is how hash old can your machine be or vehicle. And that is, of course, how many people can you danger and hurt.
Yeah.
So if the machine going faster, of course, you need to raise your barrier on the performance level, and that will have a big impact for it.
That's a good point. Okay. How do cybersecurity regulations impact overall machine security then?
I think I will move the slide and talk about the threats we're seeing. So I would say these threats will be all over the place. I would say on the left-hand side, we would like to symbolize the V model as a design tool. And you can also see the manufacturing on all the hardware we will have as well. That portion of it is actually in the office environment. Who can access your PC, your computer, and how to store the data will have a significant impact of it. And then, of course, on the right-hand side, you see who can tune the machine, how can that be implemented, and can that be changed? But we should not also forget the manufacturing, how to make sure the controllers where you built in the safety in your machine are actually the controllers you had from the manufacturer from the beginning. So we will talk about, safe boot up. It's a very important piece. We can talk about how to get an authorization, how to download software. So it's happening a lot about the admin around to protect our machines for a threat and a change.
Do you have any parameters from where the cyber threats come in primarily?
I mean, some of you have probably got these scooter bikes, electronic. Buy it from an East country, you can probably tune it. So if that was designed for 15 kilometers. Wow, I get a new software. It can go 40. Wow. Consider now if you're doing the same thing with a machine. You're spending a hell of a lot of time, sorry for my language, on the design and the safety procedure that you limit the speed to 30 kilometers an hour. Someone changed that with a parameter to 50. Everything what you're putting in your machine will be inertial. The braking circuit, the redundance, what you need to design in, will have a major impact on how safe your machine will be.
Okay, so that's the impact of a threat. But if I'm a hacker, where would I likely go for an entry point into your system?
Can be all over the place. You can see the arrows coming out here. It can be directly into the PC for the designer to say, I will always have access to your machine. Not good. Or it can be on the service level. So I think we need to consider. But one thing what is important on this Terra, this is the threat analysis you need to do, is to define where you see the threat. And that threat will actually increase or decrease the level of security you need to have in your application.
So what can we do about the threats, Nils?
We will start to put in authorization onto it. So we have that. And the selected, what we will talk about in a minute, what the product, what we're working on, actually are designed in the microcontroller today. You actually already have built in a cybersecurity functionality, what gets used when you actually do the firmware design of it. So it actually starts with the whole life cycle on the product from the design and moving forward.
Okay, so we'll get to that slide in a little bit. But first, Rich, what types of global standards govern functional safety for mobile equipment?
Yeah, so there are a number of functional safety standards, and of course, there's a little bit of interaction between off-road and on-road, but for our purposes here, most of our off-road customers, they're looking at an ISO 13849 requirement, which really governs construction equipment, anything that's not on the highway. And so it is a lot of things in that requirement, but from a component standpoint, it's how do we build components that can, for instance, safely release stored energy as required, right? So we don't create a condition where we could injure the operator. And then, there's other things in the safety element at the machine level or the system level we have to take into consideration. So what I say is we have electrical piece, right? We have to design safety, but also everything else that goes around it, whether it's brakes on traction, hydraulic systems, all has to be considered for safe machine design.
Okay. Rich, how does the electrification of mobile machines make designing for safe operation complex or more complex?
Yeah. So a couple of things that happens, right? So from let's say a Parker standpoint, we're not only, in a lot of cases, we're not just controlling the hydraulic system, we're controlling the propulsion of the machine. So what used to be done, it was the onus of the diesel manufacturer and the transmission manufacturer, has now shifted to us. So we have a big footprint on that customer's equipment. So the safety is not just the hydraulic piece, which we've been doing for a long, long time, and how do we handle the electric side of that, but also that vehicle is moving. And what happens when it's unsafe? What do our components do to contribute to the safe operation? It's really complicated. It takes years and years to validate all this. So it's quite a high hurdle.
Okay. Which functional safety affects electrically driven systems?
Yeah, so in our case, the base level for most of these customers here is the ISO 13849. And there are various implementations from our equipment. They tend to, from the electrical side, they have to do with safe release of energy. So think about, you asked a little bit difference between past car and construction. The mass is so much larger, right? We're 50,000 pounds, 80,000 pounds. So we're dealing with big loads, high inertia. So our components have to really be produced so that all that energy is removed somehow, right? In a safe, controlled, repetitive, predictable manner, right? We don't want to have things just go crazy out in the field. If the operator feels unsafe and needs to bring that machine to a stop or take hydraulics off, it happens the same way every time.
Okay. Is there a particular method of doing that? Is it sort of segmentation or what's?
So in the ISO 13849, there's several implementations of functional safety for our product. So one of our products are the controllers for the motors that drive both hydraulic pumps and traction. So we incorporate a function called Safe Torque Off. There are other functions. Safe Torque Off essentially is if there is an unsafe condition, there is some contact that's made, it tells the controller, we need to remove all this energy. And these are big motors, high power. The controller then has to go to a controlled shutdown. So Safe Torque Off is not the only one, but it's one of the critical ones that we implement in our products and that our customers are looking for.
Any other product features that help with the cybersecurity?
No, I mean, what Rich said, it's so important to have the whole from the controllers into the electromechanical piece where the inverter is designed for it, and then it continue to the driveline or to the implement side and just moving over. So you can't just say it's one piece of it; it's complete chain.
Yeah, I'll throw in. So I have a photo here. It's not an off-highway piece, but I think it illustrates
Right.
safety. So we have a bucket truck, right? An operator is up working on a telephone line. And in this case, it's all electric, right? So a couple things have to happen, right? We have to brake that vehicle safety. So we don't want the motor working against the brakes. And of course, when the brake engages, we need to make sure the electric motor isn't fighting it. And in the hydraulic system, when we have a safe torque off event, the motor stops spinning, the pump stops spinning, we lose all our hydraulic power. So now that person is up, sitting up there high, we need to also factor in the hydraulic system, all the safety, the valves, accumulators, things that we need from a hydraulic point. So a lot of our safety combines these two elements. It's not just in the inverter, it's the total system design.
Why is Parker particularly good at combining all those aspects?
I'll start. I think, so, we have at least, 40 years of mobile competency and electronics. I mean, we've been with our ICANN products, I think, since the 90s. We have been in industrial automation for 40 years, and a lot of the same considerations in safe operation of motors applies to the mobile industry. So we've had 30, 40 years already of experience in designing equipment, and we're bringing a lot of that knowledge into the mobile industry. So we're really well suited. Plus, we speak both languages at Parker. We're not just a hydraulics company, we're an electric company, and our people increasingly are becoming more proficient at talking those two languages.
And Parker develops the software themselves as well, right?
Yes, we do.
We do.
Okay. What's the future of cybersecurity?
I mean, as you can see here, the Resilient Act is actually a big thing for us in Europe. We need to comply it really and have product ready for the European market to December 2027. So it's happening now.
Yeah.
Our customer working now with how they will implement that on the office side and also on the side what we have on the machines. So you can see here we working now heavily to get ready for it, but we cannot wait to December, 2027. Yeah. We need to do it now. So we're working hard with our customer to be prepared. So you can see the two product lines, really what we have up here. The inverter side, what Rich are talking about, they are working to get that compliant in time, and the same thing on the controller side. So we will be here, and we would like to help our customers really to take that journey together with them. So it's actually for our customers, this compliant need to be ready. So it's not only for Parker, it's for our customer. Mm-hmm. And I would say the way which we can help our customer to be prepared, I'm very proud of that.
So what is the main thing that you need to consider for the Cyber Resilience Act, or the top 3 points that you would say to your customer to consider to be ready for CRA in December 27?
I would say the key point is when we work with a customer, do we have a same understanding what we would like to do? Because this standard is huge. and we cannot fool all pieces. It will be elements in the standard, what will be the key element. And we need to be aligned, so we're working on the same portion into the standard. So that is probably the most important part when we're moving forward.
Okay, what about suppliers who say, I don't have anything to do with the European market, so this doesn't affect me? Should they be taking into consideration anyway? Is it a gold standard, something that other countries should also?
I can tell you 2 years ago, cybersecurity was an abstract thought, right? Like we knew it was coming. I think in the last 6 months, it's become an imperative and there's a date. And I think it's happening sooner than we thought. And I can tell you from machine design, right? In the United States, for example, we kind of follow the standards that come out of Europe. And so I'm quite certain. So what happens typically, the big OEs here in Europe drive a lot of these standards, gets enacted through the EU. Our customers are global. So Nils will have a conversation with the customer. 6 months later, his counterpart, right, at the customer in the US calls us and says, hey, we're told we need to implement this. So the good thing by working globally, we can stay in tune and work together because this is a global effort, right? We have these same products made in both countries in some cases. So all the design process has to be replicated both in the States and in Europe. So it's pretty seamless for us.
Okay. Does it affect any aspect of the benefits of digitalization, this Cyber Resilience Act?
I would say have a lot of benefits. I would say together when you have starting to put the key products into your system, you're actually there for a long, long time. You will not be replaced by another controller because then the whole security level will fall in pieces. So when we're doing this with a partnership, it's not a partnership for one project. It's a partnership for a very, very long time for the next generation machine. The machine will come afterwards because this is not only for one time. It's to actually manage the whole product life cycle, not only for Parker, but also for our customer. So it's a long-term commitment we're actually going into.
But is there any influence on uptime? Let's say, customers say, "Oh, I can't be bothered with that. I want my machine to be working at all times. I don't need it to shut off." Is there ever that discussion with customers?
It will probably come. That will be a tricky one because it's not designed to be swapped out. Everyone need to be there and keep their promises.
Mm-hmm.
Yeah, I think you could envision a lot of scenarios, right, with hackers and potentially taking a machine hostage and getting an email like, I control your $10 million machine, send me money, send me crypto money. So I think that's the worst case. We focus more on the safety aspects, right? How can the process be penetrated? Also, I think the end user, we don't talk about the end user, we always talk about the OE, but somebody's going to own this equipment, right? And they have to be somewhat aware, like they can't do certain things. They can't just go in with hacker software and go into the firmware because this was developed over 3 years, millions of dollars of investment, and all OEs are dealing with this right now. Like we build all this safety in, and we can't have people going rogue, right? Like we see in the US, doing their own thing and causing, then, the machine, something bad happens, right? Who do they come back to? So that's another effort, I think, to get that to the end user. And they're probably a few years behind us, right? I don't think they're thinking about
You
this.
mentioned the right to repair.
Yes. Yeah.
So is that one thing that comes into the balance sort of when people are electrifying?
It's a huge political discussion. So I come from the OE side, and I see the engineering effort, the number of people, the millions of dollars complying with these processes, which are very labor intensive. And then, the machine ends up in a farm that's 300 miles away from the dealer. And I understand the poor person that owns the tractor wants to get his machine running. But as an OE, we really are not in favor of that, right? Or as a supplier. I mean, I understand the end user and his frustration. It is becoming, interesting, a political issue in the U.S. There are people in our Congress, right, who lobby for the folks who have these machines. We certainly understand it, but we have to understand what went in to make these machines safe and how much effort the suppliers like us and our customers, we don't want people just going in and,
fiddling with it,
buying some software offshore and going in and modifying the code.
Okay. How do cybersecurity requirements impact Parker's products? Could give us some
Huge.
more examples.
I would say it coming back to our internal design processes.
Yeah.
That's where it starts. If you don't have shaping up your design processes, we can't survive in this world. So I think engineering, but also the life cycle. We talk about how to put a product into a machine, but also when it's time to take it out. Do updates. I mean, we have, especially in electronics, we can get a lot of components what need to be replaced rapidly. And that will have an impact how to do an upgrade on the hardware and how to make sure we also do not cheating in these procedures, how it is. So it will have an impact for all of us.
Anything you'd like to add to that, Rich?
No, I think Neil's covered. The one takeaway is cyber is not a component or a thing you put in. There are some chip requirements, right? There are some design requirements. It is a lot of process. It is a lot of how you write code, how you allow corrections to meet. So it's a lot of people come to you and say, give me a 30-second briefing on cyber. It's really, really tough to do, right? So we're all learning, though.
And as far as machine optimization and machine service is concerned?
I think that will have a smaller impact, but you need to have the authority to do the optimization. So you know what to do. So the designer of the software sending then like a access with a vault, and then that can have an access down to optimize machines and all that. So for the technician what do the optimization, he will not see any different. But everything what is in the background, what you can adjust, how much, how less, that have an impact.
Okay, thank you very much. We'll open the questions to the floor. Anyone would like to ask our speakers anything about cybersecurity in your mobile machinery? Well, not at the moment. So if I'm a customer and I'm interested in cybersecurity, which part of the booth should I head to find out about the Parker solutions and products?
Digitalization and electrification. It's just the two podium, what you really can see, what good products, what will be impacted of what we just talked about. So please take your time and go out. And if you have any question, please come up to Rich and myself. We'll be happy to help you out.
Nils, Rich, thank you so much for sharing your vast insights. It's been a pleasure to talk to you. Thank you for your attention. Round of applause for our experts.